Here we have to follow a task. We have the function f of x equals a to the power of x, where a is the base of the exponential function and is a number bigger than 1. A is a number bigger than 1, and we want to calculate the McLaurin series of the function above. First we have to find, so my function is a to the power of x. My first derivative is a to the power of x ln a. The second derivative of x is a to the power of x ln a times ln a. So that's a to the power of x ln a squared. The third derivative of x is a to the power of x times ln a to the power of 3. The fourth derivative is a to the power of x ln a raised to the power of 4. The nth order derivative of the function is a to the power of x ln a to the power of n. Now let's evaluate all the functions and the derivatives at 0. That's just 1. For f prime, first derivative is just ln a. For the second derivative, evaluated at 0, is ln a squared. For the third derivative, evaluated at 0, is ln a to the power of 3. The fourth derivative evaluated at 0 is ln a raised to the power of 4. And for the nth derivative evaluated at 0 is ln a raised to the power of n. So the f of x is f0 plus f prime of 0 times x, f second derivative evaluated at 0 over 2 factorial x squared, plus third derivative evaluated at 0 over 3 factorial x to the power of 3. Let's take more terms. F fourth derivative evaluated at 0 over 4 factorial x to the power of 4, plus higher order terms. The function evaluated at 0 is just 1, plus then the first derivative is ln a x, ln a times x, plus the second derivative is ln a squared over 2 factorial x squared plus ln a to the power of 3 over 3 factorial x to the power of 3 plus ln a to the power of 4 over 4 factorial x to the power of 4 plus ln a raised to the power of n over n factorial x to the power of n. So my function f of x can be written as the sum from j equals 0 to n ln a raised to the power of j over j factorial x to the power of j. Or I can write it from j equals 0 to infinity ln a to the power of j over j factorial x to the power of j. You see here that if I take a to be equal to e, what I get is f of x equals the sum from j equals 0 to infinity ln e to the power of j x to the power of j over j factorial. And from here I get the infinite series. ln e is 1 to the power of j is 1 times xj, x to the power of j over j factorial, which is the approximation for the exponential function with base e, where e is Euler's number, is an irrational number. So let me write it clearly, xj. We approximate it by McLaurin series. X to the power of j over j factorial. And we can derive expression for generalized hyperbolic functions like sine hyperbolic a cos hyperbolic a tan hyperbolic a and cotan hyperbolic a, which is the 1 over tan hyperbolic a. And here the denominator, of course, should be different from 0. So my domain, the domain of the function is all the values except the value of 0. Yeah, these are pretty cool functions, the generalized hyperbolic functions, and you can use the McLaurin series to find the power representation of these hyperbolic functions.